We'll also be doing it with variables. But variables really are not that hard if you just catch on to one little thing. All right, so let's look at this example here. They've got 15x squared minus 10x, so that's two terms. So the first thing we do is look for a number, or the largest number, the largest factor, hence the greatest common factor, that will divide into both 15 and 10. Now, hopefully it should be kind of obvious without having to do the tree there unless you really want to, that 5 is that common factor. When you have numbers that divide that end in 15, end in 5 or 0, those are factorable by 5. So 5 is one of the factors of these two numbers. Now, let's look at the variables. Here we got an x squared in the first term, and the second term has got an x. Well, here's the thing is, if the variable is common to all of the terms, then you simply take the variable with
we lost you, Mr. Cruz.
No, I don't think he can hear her.
then we hold on a second. Oops.
We lost you for a second there.
Am I back?
Yeah, you're back now.
Okay. Yeah. Well, you know how the internet is. It'll dip and all that. So I'll just kind of back up. So common factor to both 15 and 10. They both end in either 0 or 5. That's one of the things that's common about a factor of 5. You can go through and factor and do like a factoring tree for these if you want to. That's always work, because if you break something down into its common, to all of its prime factors, you can easily see what to take out. But there are other little things too. Like I said, is numbers that end in both either 5 or 0 are divisible by 5. So 5 comes out. Now we've also got x's right there. All right, an x squared and x. Well, for a variable greatest common factor, it's the x term that's got the smallest power. So that would be this one right here, just a plain old x. So the greatest common factor is 5x. Now, how do we determine what goes here? Well, we put in these two places what it takes to get back. Now, this is where you can go back to division, because you remember division and multiplication undo one another. So if we were to just look at $15x squared and divided by that 5x, well, 5 goes into 15 3 times right there. And x divides into x squared, because this is a 1. 1 from 2 just leaves x single, and that's that right there. So for that second term, it's negative 10x divided by 5x. The x's are just going to take each other out, but 5 goes into negative 10, negative 2 times. So there we got it. So if we multiply 5x times 3x, we get 15x squared. 5x times negative 2, we get negative 10x. All right. So that's the procedure. So what I would like you to do is look at the first two right here and find the greatest common factors of those. Now, these right here, people have a tendency to kind of give up and just use that. So don't worry about that on these first two. You're not going to need them.
For the first one, I got 4 times x minus 4.
That sounds good. Let's look. Anybody else got one?
For number 1 or for number 2?
Well, for one, to start.
Oh, it's the same one. I get the same.
Okay, so look at the two numbers, 4 and 16. 4 and 16. 4 will divide evenly into 16, so we can use 4 as the greatest common factor. Now, there's no x term on this one. If this one had an x squared and that one had an x, then we could go ahead and factor out an x, but there's only the number 4 that's common to both. So what times 4? Well, again, 4 goes into 4x, x times. And then 4 goes into negative 16, negative 4 times. See that? So 4 times x is 4x. 4 times negative 4, negative 16. All right, try number 2. Anybody got questions on that one before we take off? Number 1. Okay, go ahead.
Okay. For number 2, I got x times x minus 3.
Okay, so x, there's no number that's common to both. This is a 1 here, and that's a 3. So if 1 is the only thing you can factor out, you don't really need to pull it out. And I'm going to say that lightly because in 6.2, there are some instances, and I'll explain, where it will be helpful to factor out a 1, especially a negative 1. So the only thing that's common are x's, and we use the x, the smallest power of x. That's x to the first power.
Yes, so x squared.
Good, x squared. And then here we got to have that sign, and that would just be negative 3. Correct?
Yes.
All right. Good. Any questions about that? Oh, I forgot something. I was going to turn on this live transcript. And what that does is, if I ever do go out, I forgot, audio, you can see the words that I'm speaking. And that way you'll know for sure if audio's out. And you click on closed caption to turn it on your thing down on your toolbar. All right, so go on to number 3.
Number 3, I got 2x times x to the 4th plus 3x to the 2nd.
Okay, that sounds good. Now let's look. First thing, 2 and 6. 2 is a prime number, but it divides evenly into 6. So 2 is the largest number we can take out. And then we look at the variables. Each one's got a variable. So we take out the smallest power, which is x cubed. All right, now we already got a 2, so we don't need a 2, but we're going to need to have an x. And how many x's do we get? 3 minus 5 is
x squared.
X squared. Plus sign. Well, what times 2 gives us 6?
3.
3. And again, you can also divide. 2 into 6 goes 3 times. X cubed into x cubed goes 1 time. So it's just a plain old 3. All right. Any questions about that one? All right, we'll go on to this next one, number 4.
For that one, I got 5x
Okay.
times 3x squared
Okay.
minus 2x plus 1.
All right. Anybody else come with anything?
I have the same.
All right.
I have 5x squared times 3 minus
Okay.
2
All right.
plus
what?
1.
All right. Now I heard you say x squared up in the front.
I meant the 3x cubed.
Okay, you got to look at the smallest power of x. There's 3 x terms. So we look at the smallest power of x as our greatest common factor. So that's this one right here. So it's just 5x. 15, 10, and 5 are all divisible by 5. And each one of these 3 here are also divisible by x. So that's your greatest common factor. Does that make sense? Any questions? Because you can't factor out something power-wise that's larger than that number. Because what you'd end up having to do is, if you had x cubed here, x cubed here, when you'd have to have an x to the negative something for that to come out like that. So it's always the smaller power. All right, so 5x and we need 5x into 15 goes 3 times. X into x cubed goes x squared times. Negative 10, so we're going to have a negative sign. 5 goes into 10 twice. X into x squared goes x. And then plus 1. Because 5x times 1 is just 5x. Questions? All right, so go ahead on down to number 5 and then try 6. Tell me what you get on 5 and then give me a few minutes on before we jump to 6.
I have for number 5.
Yes.
X squared times 2x cubed plus x minus 2.
Yeah. Number wise, there's nothing but 1, but we're looking at the variables. There's x squared. See, x fifth, x cubed, x squared, smallest power of x. All right, so x squared into 2x fifth means 2. X 5 is 3. This one is just a plus 1x, because if we have x times x squared, we get x cubed. Here, the sign comes along because this is positive, and we need another 2 negative, and x squared into x squared is just 1, so we're just going to leave the 2. Okay. All right, what about number 6? Get us start on that. Tell me what you come up with.
Oh, sorry. Oops.
1. Damn, I forgot how to do that one. It would be 1.
Yeah, I factor out a 1.
What's that? Well, if you can factor out a 1, it's just going to end up we'll just say prime for the time being, if that's the case. I will tell you though, this one is factorable, but we won't be able to factor it until 6.4. Actually, well, it'll be Wednesday that we'll go over that. 6.3 and 6.4, they're alternate methods. We'll be looking at 6.4, but that is factorable. It's just that number-wise, there's nothing common to all three numbers, and there's not even an x that's common to all three. What this is a trinomial, but for right now, we're just going to say prime. And probably the best thing would be to say no GCF. It would be the more accurate thing to say on this.
So in the future, like in future assignments or whatever, we would be able to factor that one out, right? Because wouldn't it just be one, like with like just the same thing, but like with one in front of it in parentheses? Well,
no, it's going to be factorable as two binomials. In other words, let's see, I'd actually work this out. It would be factorable like this. But like I said, right now, you don't have to worry about this, but this would actually be what it factors down into. So to say that it's prime, I mean, that's going to be fine for you doing work in this section. But there's just no GCF, but it can factor as this. But for right now, you don't have to worry about that. Now, when you get up into 6.2, I'm sorry, 6.3 and 4, yes, that's factorable. We're not worried about that right now. Okay, number 7. You might want to rewrite it largest to smallest. I don't know that that's really necessary, but you know, go ahead and work on 7 and 8 if you'd like. You know, it's kind of like for the same reason why, like, if possible.
I have for number 7. Number 7 is the GCF times 3.
Okay.
Minus 5y plus 7y squared.
All right. That sounds good. I'm just going to rewrite what, and the reason why I'm doing that is because usually that's, at least for me, I mean, there's certain things, like I said a little bit earlier, was getting into. If I'm solving for x with variables, I just generally feel more comfortable having my x on the left-hand side and my numbers on the right, but you don't have to do that. But anyway, I'm rewriting it like this. And I think I heard Nicole say 7 is the common factor to all three of them.
That was true.
Oh, it's I'm sorry. Oh, I was looking and I thought I saw.
We sound alike.
Well, I don't know. It's hard thinking about math and thinking about people at the same time. That's why I make mistakes, you know, because you have to write and talk at the same time, you know. I can only do one thing at a time. Otherwise, I do stupid stuff. Anyway.
Okay.
So 7y. So 7 times 7y squared. Because there's no y common to the 21, so we can't factor out a y. Here we need the sign, and we need the negative 5y. And then 21 is divisible by 7, because 3 times 7 is 21. So that's what you were talking about, wasn't it, Trinice?
Yes, sir.
Okay, great. All right, so try the number 8. That one is just going to be a little bit tougher because you got 2 variables in there that may or may factor out. Look at the numbers first, though, then look at each of the variables. Same rule, though, is the variable with the smallest power.
It doesn't matter how you write it.
What do you mean? I mean, generally speaking, you put the greatest common factor in front, open up parentheses, then put the new terms inside.
Yeah, because we got the same thing, but I just wrote mine's backwards. You got your 7y.
Well, that's what I'm saying is, look, this is what I was trying to explain about the reason why I do this. Later on, when we factor these quadratics, I think it's a whole, and we'll get that after in a little few minutes, actually. It makes these a lot easier to handle doing that. And that's why I did it, just to show you that, because I think it's going to be good practice. But you can decide if you can factor the trinomials we're going to see in a few minutes, then that's great. I like to write them like that.
Professor Pools, it looked like you just put the variables in descending order.
Yeah, that's generally what's considered simplified. Although I don't know if they care in the.
They actually don't. They specify that on the practice when we do the practice questions. They should specify that it's not, the order really doesn't matter.
Yeah, and it doesn't. It's just that it'll make what we're going to do next easier. I'll just show you in a bit what I mean. Go ahead on to number 8.
Okay, I don't know if I get that one right, but I have 3xy times xy squared plus 2x squared y.
All right. All right, so number-wise, out of the 3 and the 6, 3 is the prime number, and it divides into 6, so that will take out greatest common factor. Look at the x's. There's an x squared and an x cubed, and so we can take out the smallest power of x. And then the y's, they both have a y term, smallest power of x, so y squared. All right, so 3x squared, y squared. All right, so now let's open up our parentheses. And we don't need a number because we got the 3. And you know what? We don't need an x squared because we got an x squared. But we down one y, so that's what we put there. A plus sign. And how many, what do we have to multiply by 3 to get 6? Well, we need 2. And we also need an extra x because all we got is x squared there. We want to get to x cubed. So does that look good?
Yeah, that's what I got.
But what about that?
About what?
Because let me see here. Because it's 3x squared, right? And you just elevate the 3 to the 1, so there is a missing x somewhere or not?
All right. Let me see if I can show you. All right. Make it a little bit nicer.
Okay. Oh, so it's squared. Okay.
All right.
Oh, now I see.
Oh, you see it? Okay, it was just that. Well, I was just going to say, the way you tell is you just divide this into both of those terms. 3x squared y cubed all right, so let's just kind of show in case people are having questions. All right, so the 3's are gone, the x squareds are gone, and the only thing that's left is y cubed over y squared, which you remember is y to the 3 minus 2 is equal to y. That's why that y is right there. All right? Likewise for the other side. All right, so and so 2 from 3 is just 1 over plain x. That's why you got that there. All right. So any questions about any of those? We're going to continue doing it, but in kind of a more practical way, why this is useful, can be useful in it. Well, one way it can be useful. But I just want to make sure there's no questions.
I have a question about the homework.
Right. What about it?
So it says find the prime factorization of the number 10, which is just 2 and 5, which I'm like putting it in and it's saying it's wrong.
Well, you're going to have to show me a screenshot about why, because it's probably, so let's just say, let's kind of go back up here. So it was 10, right?
Yeah, it's the prime factorization of 10.
So it's 10, it's 2 and 5. So those are both prime numbers. I don't know. Read me the instructions on what it says to do.
It just says write any repeated factors using exponents, but none of them are repeating. So...
You don't have any repeating. So does it say anything about separate with a comma or?
Like I've tried separating with a comma, like without spaces between them, with spaces between them, no comma, like.
All right. I'll tell you what I'm going to do. What problem is that? What's the number on the, what section is it in?
Number 8, it's the factors and greatest common factor review.
Okay. Okay, say that again.
So it's question 8 on the factors and GCF review.
Okay, hold on a second. Let me find it. All right. Factors in GCF review?
Yes.
All right, let's see.
Is that the one where you have to find the sum of the two numbers?
Well, I don't know. That's what I was trying to see. Just what
It just says find the prime factorization of the number 10, write any repeated factors using exponents. So like,
Maria, you try clicking on the question help to see what it says?
I mean, I didn't, but like, I know that the answer is 2 and 5. Like I even I Googled it too to check and see. It's like, I know it's 2 and 5. So
yeah, you're right. Okay,
I don't
what
know if
problem
I'm
was
typing
it?
it in. It's number 8. I'm not sure if I'm typing it in wrong.
Okay, that's what I want to look at the instructions. Just hold on. I'm getting there. Question 8.
Elena, it looks like it wants you to put it like a multiplication, like 2 times 5.
Oh, yeah. That's what they want. Yeah, I'm sorry. So you got to put a multiplication in between the two. So 7, like if it's 2 times, that see down at the bottom, they have that multiplication dot.
Right.
That's what you got to hit in between them. It's not a comma. You just you hit the dot. So that means 7 times 5. So that's what they want.
Okay. All right. Thank you.
You're welcome. All right. So let's go on to this stuff here. And we're still going to use the GCF. We're going to use it in something called factoring by grouping. Now, factoring by grouping is very useful when you have 4 terms and you don't have any common factor all through all 4 of them. So you see what they do is they break it in half, and then they take the GCF out of the first 2, which is an x squared, and then you write back to x plus 2, and then over here you take out a 5 out of these 2, and then you have one that repeats, and so you can rewrite it. And the reason why you can rewrite it is this. There's a, I forgot what this thing is called. But it's just a shorthand way. Oops, that's not what I wanted to do. Hold on a second. This is what I wanted to do. All right, C is common to both. So rather than write it twice, we'll just write it one time by factoring it out and writing it one time like this. Factoring out that GCF. Now, the reason why, though, it's a little bit different is because here the C is a binomial. But notice what they do. They take the repeated one and write it one time, open up new parentheses, and they put this one there first. And then they take this one along with its sign and put it right there. And you can multiply these out until you'll get back to what you got. So watch. X times x is x cubed. X times 5 is 5x. Inside is 2x squared. And 2 times 5 is 10. Now, other than it being in a different order in the middle, which is easy to fix, and it's putting it in descendant order when we do that. Same thing, okay? So that's what we want to do. Well, here's another example. Now, the reason why this one is kind of important and why they got a second example is this third term here. That's the sign that goes right there. Whatever the GCF is going to come out with the sign of that third term. So here, the third term is negative. So we're going to have to just keep that in mind in a second here. So factor, cut it in half. On this side, there's 5 and 15, so 5 comes out. There's x common to both, so we take that out, and we write y minus 3 and close it back up. Bring down that sign. Then take out the GCF between 6 and 18 is 6. Open up y minus 3 to get us back to there. Here we have the one that repeats. So just like the top one, we write it one time, and then we compose the next binomial by taking the 5x and putting it there. And then this thing with its sign comes right there. All right, questions about either of those examples? All right, I was going to say something. I'm going to I was looking at the grades. There's people that did good, but there was a couple people that I would like to have seen done better. And then I went and looked at their quizzes and such. And their quizzes were about the same grade as what they got on their, their exam. So please take advantage of those quizzes. And if there's not enough attempts on it, I can't remember what it is, I'll be glad to raise them up for you, because that's how you practice for a test. I mean, it's one thing to do the homework, but the homework, you got to remember, it's got those helps. So you need a bridge between the actual exam / test and, your practice tests or quizzes or whatever you got. All right. So if you want to be able to do those until you can get as many, till you at least get a passing score, because some people even go, from what they practice, because they're just kind of generally nervous about tests. But I just wanted to point that out, because there's people in here who can do a lot better. And really, it's a pretty easy fix. It takes a few more minutes to do it, but it'll pay off. All right, so try number 9 and 10, and then we'll take a look at it in a few minutes. So that's where you want to cut and snip. 2 on each side.
I have number 1.
Okay.
So I have, in a parentheses, x plus 5. And I close the parentheses. And then the other one I have 5x plus 3y.
Okay, so you get the whole thing. All right, good. So what we're going to do is, on this side, take the GCF, and that's going to be a 5, because 5 is a prime number, so 5 goes into 25 5 times. X squared and x, the common factor, is the smallest power of x. And then here, what does it take to get back to there? Well, 5x goes into 5x squared 1x time. 5x into 25x goes 5 times. Is that right?
Yes.
All right. Take this sign down there.
Mm-hmm.
All right. That sign you want. The sign of that third term is going to go right there. Now, out of 3 and 15, well, 3 is prime, but it does go into 15. So I'm going to put 3 right there. And anything else that's common, which in this case, it looks like a y. Now, 3y into 3xy leaves 1x when we divide. Plus 3y into 15y goes 5 times. All right. Now, we're going to rewrite these because I say this, here's the repeater. And if you did everything right, those two will repeat. So I'm going to write it one time. And then I'm going to put this one right there, the first one. And then I'm going to bring this down and put it right there. And you can multiply these out and you'll get back to that. X times 5x is 5x squared. X times 3y is 3xy. Inside is 5, or 20 times 5 is 25x, because there's just one x, plus 5 times 3 is 15y. And the only thing that's different is these are turned around. And truthfully, it wouldn't have mattered if you factored it when it was in the shape. Either way, you'll come out with the same thing. So try number 10. 10.
For the answer, you just want the last part?
Well, yeah, I mean, that's all right.
All right.
And I'm going to ask, I'll ask you some questions as we go through and solve it. But yeah, what do you got?
I got 3x plus 5 in parentheses plus 4x squared plus 5.
All right, let's see. Anybody else second that?
Yes, I got the same.
Okay. So let's look on this left-hand side. Out of the 12 and the 20, the only thing that's common is 4, right? So kind of what we're doing is, I was going to see if I could like have some room here to show you, but so here's the common factors. If you like doing it like this, and you can't really see all of them, this is a good thing to know. So you got 3, 2, 2, and then 20 is 5 times 4. So that one's prime. So then what's common to both of them is 2 times 2, which is 4, okay? So that's where that comes about. So 3x cubed, oops, I'm sorry, there's an x squared there. So 4x squared, and then there's a 3x plus 5. Close the parentheses. And then on this side, the only thing common, like I said, is you can so there's your prime factorizations. These are pretty easy because they're just one iteration. So 5 is the greatest common factor. Oops. What did I do? So bring down that sign And then the GCF, like I said, the greatest common factor between these two is 5. And so 5 into 15x is 3x. 5 into 25 goes 5 times. So here's the repeater. And there we go. All right. Wonderful job. All right. Any questions about those? You can jump on 11 and 12. But if you got questions, let me know.
What did you write in the second parenthesis?
4x squared plus 5.
Okay, I thought that was, I was just making sure that it was a 4.
So here, that's where you're going to divide. Here's where you're going to divide.
Four.
All right. So on these, just when you get, just tell me you're done. You don't have to read them out because I want to.
I finished 11.
You got 11?
Mm-hmm.
If anybody gets 12, let me know when they got it. You don't have to give me the answer yet. I just want to know that we have had enough time for a couple people to get them. All right, so on the numbers, well, first of all, you got an x cubed and an x squared. So that means you're going to have a power of x out. So it's going to be x squared.
Yeah, I got 2x squared.
Yeah, and the thing is, like I said, if you need to do it like this, you can do that and see. It's the greatest one you can take out of both the 6 and the 16. 6 is 2 times 3. 16 is 2 to the 4th power, or 2 times 2 times 2. So 2 is the largest one you can take out. So then what does it take to get back to 16? I'm sorry, 6 is 3, and an x. And then 2 times, this is actually 8 right there. 2 times 8 is going to be an 8. Now, here's what I said is, you bring down this sign. That's important. Now, out of these two, there's no x common, but one ends in 5, one ends in 40. So 5 is a common factor. -5 times, or -5 into 15x is 3x. And -5 into -40 is +8. All right, there's the repeating one. So there we go. Any questions? All right. You'll want to do that last one. When somebody gets the last one, one or two people, just let me know, and then we'll go through it. Has anybody figured out what's the factor, the greatest common factor out of these two? Again, so we're like this. One ends in 5 and one ends in 0. So
it's -1. 5 and -1.
A 5 out of these two, right?
Yeah.
Any variables? Yeah, there's an x and there's an x cubed. So that's going to be just a plain old x that comes out. All right, now 5x into 5xy means there's a y left over. Bring down that sign. 5x into 20x cubed is 4x squared. Close it off. Now, as I said, as you bring down this sign, now here's what I was telling you about 1. Even if it were a positive there, we would still want to put a number there because this is going to factor as a binomial. So the only thing that this has common is a negative sign, which is the same thing as -1 times. So -1 into -y goes y times. -1 into -4x squared goes plus 4x squared. These repeat now. And then 5x. And then, like I said, this is where you need a 1. Even if it had been a positive 1, you bring it down because it's going to go here in order to complete out that binomial. Okay? Questions on those? All right, so let's take a little break and we'll come back in 10 or so, and we got another one to handle. Whoops. Pause. All right, so can y'all folks hear me?
Yeah.
All right, good. All right, so 6.2 is called factoring trinomials in the form x squared plus bx plus c. Now, what that essentially means is that's a plain old x squared. In other words, 1x squared. So the method that I'm going to show you here, and I'm going to try to, I think this makes the procedure a little too complicated. So I'm going to try to make it a little bit less. So, all right. So here's what we got is, in this first example and the problems that follow, you're looking at a positive number right there. All right, first of all, in order for this to be a positive 36, they got to be the same sign. All right. Well, what sign is it going to be? Well, this part right here tells you what sign it's going to be. Whatever the sign there, all right. Now, this is why I suggested making sure that the terms were sorted left to right, you know, highest power to lowest power, because otherwise it's not in this form and it might be hard to see. If you're, you know, what like I said is if you learn the method to factor these things, then by all means, just keep on doing it, because I know that there are probably just about as many methods for factoring these things as there are teachers. So just if you've got something that works for you, don't feel like you're going to, you know, impress me by using my method. But I'm just telling you, the last number there, the sign, positive number, all of these are going to be positive, tells us we're looking for two numbers with the same sign. The sign of that middle number tells us what the sign is. All right. Okay, so the way I handle it is I'm just going to write them out that we need x minus something and x minus something. We've already determined that by looking at the signs of those two numbers. The last number, if it's positive, then we know are 1 and 36. We already know the sign, so we don't need to put those on there unless you want to. So here's all the factors of 36, 4 times 9, and 6 times 6. So down here, if you add these up, it's 12. So that's not them. 4 plus 9 is 13. So that's not our pair. 3 plus 12 is 15. That's not our pair. And then, well, the top one is 37, so that's not it. And there should always be only one pair that gets us what we want. 2 plus 18 is 20. Those are our numbers. Now, the reason why I don't like this, because I hate fooling with the negative signs and all that. We already determined what the signs are going to be up here with that. So what does that mean we do? Since it doesn't matter, they're both going to be negative, you can put them any place you want to. They don't have to be a special order. But that will get you, if you multiply it out, you'll get back to that. All right, questions about the procedure? All right, so like I said, these are all going to be the same sign. See that? So what tells you the sign is the middle number. They both have to be positive and so forth. So why don't you try the first two and tell me what you get. All right, anybody come up with any, the first one yet?
I have 4 and 5.
All right. Here we go. Let's watch, because that sounds not right. I just want to take people through the process. Okay, they're both going to be the same sign. They're supposed to be parentheses. They're just terrible. And they're both going to be plus. All right. So now we're just going to look at all the factors of 20.
5 and 4.
Yeah, you're right, but I want to go through the procedure. And I do believe that's all of them. So this would be 21 when we add them up. You're looking for the sum. So not this one, but this is 5 plus 4 is 9. That's the ones we need. And we can put them anywhere we want to. You can put the 4 first or the 5 first. It does not matter because the signs are both the same. All right. Both the same sign. What is that sign going to be? What's the sign? Well, that middle term tells us the sign. Both of these are going to be negative. So now we just look at the factors of 24. So 24 and 1, 12 and 2, 6 and 4, 8 and 3. And look at this, 6 plus 4 is 10. So that's the ones we use. We're talking about sum for all of these, for that middle term. 24 plus 1 was 25, so that's not it. 12 plus 2 is 14, that's not it. 8 plus 3 is 11, that's not it. But 6 plus 4 gives us 10. And we've already decided the sign, so that takes care of itself. Questions on that? All right, what about number 3? Both the same sign, so what's that sign going to be?
Negative.
Yes, they're both going to be negative. All right, that tells us what both signs have to be. This tells us that they're both the same if it's positive. And that tells us what the signs need to be. So now you can just go through all the factors. I think we already did this one. And see which of these add up to be 8. 6 plus 2, 12 plus 1. So this is 13, that's 7. 6 plus 2 is 8. So we just put them in there. We can put them in either order we want because they're both the same sign. All right. 4. So for 5, there's really only two factors of 5, right? 1 and 5. Is there anything else I'm not thinking about? Anything I'm not thinking about?
No, that's it.
That's only 2, aren't there? What do those add up to?
6.
But yet, there's no 6 there. So since the only factors that we have none of them add up to that middle term, then this one is what we would call prime. Now, again, when we get to the end of the class, we're going to find out there is a way to not factor these, but we'll find out, because factoring is one way to solve these type of it's called a quadratic because it's got that x squared and then an x term and then a whole number. We'll find there's another way to do it later on. What about number 5? First one that gets it, yell. Tell me what the answer is. Tell me the factors when you get it. Come on, what's going on out there? Anybody get it yet? So these both have to be positive, right?
Yes, but the thing is, if it's positive, the always was 3 times 7.
Okay, so 21 times 1.
11.
So that's 22.
Oh, yeah, times 1. I'm so stupid.
But does that give us the 4?
No.
Okay. But you need to go over that one. And then there's 7 times 3, which are 10. No 10. Am I missing another factor?
Mm-mm.
No. So I'm kind of surprised that they have 2 prime ones on here, but
Yeah,
looks like that's prime also.
I was tripping.
And there's a way to check with the quadratic, this thing called the quadratic formula. And then we're going to learn that thing called the quadratic formula before it's all said and done. And that'll allow us to take care of ones that can't be factored. All right. So these 2 can't be factored. All right. So let's go on to the next type. All right. Which means one positive, one negative. All right. So one says x minus, one sign is x plus. Now, I'm going to show you something that's a little bit different than what they're showing you. If you understand, that's fine. I'm going to write out the factors of 8. And again, I'm not going to mess with the signs, and I'll tell you why. Okay, because now we're thinking difference. All right, since one's positive and one's negative, when you calculate that middle term, well, you're going to be taking the difference between 2 things. So 8, 1, 4, and 2, which one of these has a different, what's the difference on this? 8 minus 1 is 7. 4 minus 2 is 2. So this is the pair that we need. Now, here's where we got to think about what, because now we can't just throw them in any place. We got to put them in the right place, because since the middle term is negative, let me write this here. And I'm going to put in quotes. The larger factor. So, so that means the 4 is going to go right there, and the 2 is there. Here, sign placement is crucial because you got one positive and one negative. You got to make sure that you got the larger one is negative, because when you take the difference between -4 and 2, you got -2. If you put the 4 in the positive section, that wouldn't work because there would have to be a positive 2x. All right, how does that get in there? All right. So it's x minus 4, x plus 2. Sounds like a storm's coming up. All right, let's see if we can finish these before we get a storm. All right, so negative, see all of these have negative at the end. So all of these are going to have x minus and x plus. You can just go ahead and write that so you don't have to think about it. So again, because the third term is negative, that means it's going to be x minus and x plus. Now, the next step is for each of these to determine the factors. So we got 20 and 1, 10 and 2, 5 and 4. So now we're taking the difference. We just got to remember 20 minus 1 is 19. So those are not going to work. 10, take away 2 is 8. That's not going to work. But 5 take away 4 is 1. So this is the pair we need right here. Now, because the middle term is positive, that means the larger number goes there. Okay? What in the world? All right, any questions about that? All right, so here, factors of 6. You got 6 and 1 and 2 and 3, the only factors. So what's the difference? In other words, when I say the difference, subtract. 6 minus 1 is 5. 2 from 3 is 1. This one does us no good, but here's the pair we need. So that means, since this middle term is negative, the larger number goes here. And just to show you that I'm not crazy, let's pull it out. X times x is x squared. X times 1 is x. Negative 6 times x is negative 6x. Negative 6 times 1 is negative 6. And then these combine to be See, that's 1x, 1 positive x, and negative 6x. So that's how we get that. So again, anybody come up with anything on 8, 9? I should be letting y'all do a couple of these rather than me pushing ahead. I think we got a few minutes for this storm. I'm just afraid that if the power glitches, I'll be able to stay on with my laptop, but the way I got this thing set up, my main computer is not on the power supply, but my internet is. So all right, anybody come up with anything on 8? So this difference is 7. This difference is 2. So what does that say about this one? Is there any factors I'm missing?
No, that's all.
All right, so what does that mean? If there's not a pair that works.
It's a prime.
Prime.
Yeah, it's can't be factored. So we're just going to say prime. All right, what about the next one? What about number 9?
Six and 8.
All right. Anybody else think so? 6 and 8? Six and 8, huh? All right.
I'm sorry, that's 48.
All right. So let's look. So 28 and 1. So this is 27. So that's not going to be it. We got 14 and 2, which is going to be 12. So that's not it. And then we got 7.
There's 7 and 4.
Oops, you know what? This is the one. I don't know what I'm thinking. The difference between, so this one doesn't work. But here's our numbers, because 14 just kind of minus 2 is equal to 12. So that means then, since this is positive, the larger number is going to go there and the smaller number there. So does that look good?
That looks good.
All right. So jump on that last one.
Eight and 3.
All right, 8 and 3. Anybody want to second that? X squared minus 5x minus 20. Minus 24. We'll do it on here so I got a little bit more room. Because on that last one, it never pays to skimp on stuff. Make sure you got plenty of room. Even if you have to put one problem on each piece of paper, make sure you leave yourself enough room because it can, I don't know, like I said, it can just throw a little monkey wrench into things. So the difference here is 23. So not these. 12 and 2. The difference is 10. So not these. 6 and 4. The difference is 2. So not these. The only other ones are 8 and 3, which has a difference of 5. So these are the numbers we want. All right. So one's got to be x minus and one's got to be x plus. So that means since this is negative, that means the larger number is going to be negative. So x times x is x squared. X times 3 is positive 3x. Negative 8 times x is negative 8x. And negative 8 times 3 is 24. These combine to be negative 5x plus 24. So we know we got our right numbers. Okay. Any questions about anything? We got plenty of time, so don't.
Yeah. Okay, so for the other ones, I noticed that we was just doing the negative sign since the middle number. But for these, why is it a plus and a negative?
Because the third number, the negative third term, in other words, see all of these?
Yeah.
This one had negative 8. This one had negative 20. This one had negative 6, negative 8, negative 28, negative 24. If your third term, in other words, when it's sorted, highest power, x squared, then x term, and then your number. If that third term is negative, remember, that's when you're doing the FOIL thing, that's your last. That's your last term. And the only way you can have a negative product there is if they're opposite signs. That's what there's no way other way for that to happen. When we were up here, we knew they had to be the same sign because either two positives or two negatives both give you a positive 36. And then the middle term just tells you what the two numbers have to be, the sign has to be. We know this means we have to have two numbers, either two negatives or two positives. Well, that tells us what they need to be, two negatives. See that? They have to both be positive, and then the middle term tells us that they need to be both positive. Two terms have to be the same, and the same is positive. So on this one, this is positive, so they're both going to be the same number. Well, I'm sorry, the same sign. Well, what sign is it? Both negative. Here, plus 12. They both have to be the same sign in order to get a positive. Well, what sign is it? Well, they're both negative. This one wasn't factorable, nor that one. But now, because when you add -4 and 2, you get -2. If you'd had them swapped around and had -2 and +4, when you added them, you would get +2 there. So like, for example, on this one, all right, negative third term, opposite signs. Well, how do we know what that, the sign of, since they're both different, we gotta put the positive one and the negative one in the right place, right? Well, this tells us, since this middle term is positive, the larger of the two factors, 5 and 4 in this case, has to be positive, because 5 take away 4 is +1 over here. -6 plus 1 gives us -5. That's how we knew to make the 6 negative. This was another prime one. There's no way, there's no factors that work that. Again, negative, so they're going to be negative and positive. The middle term means that the larger factor, which was 14, goes in the positive spot, and the smaller one goes in the negative spot. And then the last one, okay, again, third term is negative, so one positive, one negative. And since this is negative in the middle, that means the larger factor. Remember that I did on that other sheet to find the right combination. And so the 8 goes in the negative position, because -8 plus 3 gives us the -5. Does that make it a little bit more
Yeah, I understand it now.
clear? Okay.
Thank you.
Anybody got anything else?
So whenever you write down prime is whenever we cannot do the
Factor
process
it.
with an answer.
We can't factor it down to two binomials. It's called.
Oh, okay, thank you.
There was no factors here. See, 8 minus 1 was 7. 2 take away 4 was 2. And that's the only 2, and none of them came out to 5. So as long as we've got all of the factors that multiply out to be 8, and the difference is not, and none of those differences are 5, then we're in prime territory.
Okay, so if we have a question like that in a test and we cannot factorize it, we just write down prime, or?
Yeah, if it's true, people tend to use that though more than it is. They just forget about doing them all. That's why I suggest writing down all of the factors, okay?
Oh.
And then go through and then do sum or difference depending on the type, and make sure it's not there, because you don't want to put prime is going to be one possible answer for any of them. So don't fall into the trap of putting prime too often. Make sure. But that just means that there's nothing that can be done to factor it further. We're going to find out in chapter 10 at the end of the class that there is a way when these are equations to solve them. But anyway, for right now, these are not factorable, so we're going to say prime. Anything else? All right. Let me just show you this here. 6.3 and 6.4. Let me make sure that I didn't assign both of those. Oh, she's got them combined, so it doesn't matter. Okay. So there's one homework in there, and it says 6.3-6.4. Use whatever method you like. 6.3 is called trial and error. I hate trial and error. I'll just kind of show you. because if you know how to factor these, and there's always somebody that does, just by all means, keep factoring it the way that works for you. This is what 6.3 is. The only thing that's different about what I'm going to show you in 6.4 is 6.4 is methodical, and I end up using factoring by grouping to make things kind of methodical, because I couldn't even tell you, explain this trial and error if I wanted to. I just don't like it. I never liked it. So when I discovered factoring by grouping to do these, that's what I started doing. All right. So
Oh yeah, I saw that when I was doing the homework and I was really confused
about what?
about this that you're about to explain.
All right. So let me kind of explain this to you, just so that when we get in here next time, that let's just go a little bit more smoothly, hopefully. All right. All right. It's called factoring trinomials in the form of ax squared plus bx plus c. Now remember, on the last ones, it was this form. Can you tell me the difference between this, whoops, and this right here? What's the one difference? This just says x squared plus bx plus c. Well, in 6.2, all of these trinomials had just a plain old x squared, or it's also just a 1x squared. All of these were like that. But there are some where you have another number in front of x squared, and that number is called a. So let me just kind of show you. A is equal to 2, and then c is the third term, so c is equal to 6. All right, so this is how the AC method works, and I'm going to kind of break it down for you and make it a little bit less complicated than the way they have it. You don't need to use the variables. I don't know why they go through all that. That to me just makes it complicated. So A times C is equal to 2 times 6 is equal to 12. All right. Now, instead of how we did over here when we just looked at that last number, which is what we did on all of these, we didn't even worry about anything. We just jumped straight to that third number and looked for the factors. Well, here, we don't just use 6. We multiply 2 times 6. So now what we do is look for the factors of 12. And I'm just going to write out the numbers. That's all we need. You don't need to put all those x's in there unless you really want to. Now, it's positive in the middle. Well, it was positive 6, so that means these are both positive. So they add up to, this would be 13, not 7, so we can get rid of that. 6 and 2 is 8, so we can get rid of that. 3 plus 4 is 7. So that's the ones we need. So what does that mean? That means that 7x is equal to 3x plus 4x. So now we found the magic numbers that allows us to break that middle term into 2 parts. See that right there? That's 7x in the skies. All right. So we're purposely unfoiling at one step in order to have 4 terms and then use factoring by grouping. So then what happens? again, you're doing the same thing here. Taking out the greatest common factor of 2x squared and 3x, which is just x. And then on the inside, you'd have 2x plus 3. Again, bring down the positive and take out the common factors of 4x and 6, which is just 2. And that leaves us with 2x plus 3. And notice that that's repeated again. So as we said, you can just write it once. And then times the x, and then that sign and number. Now, the reason why I like this method, and I guess I kind of, in a way, I kind of expect everybody to like it, but not everybody does. I mean, I'm talking about teachers too. Like I said, is even though here, the author of this, they more or less did the same thing I do. I just think they made it more confusing. But the only real trial and error here is just going through all of, what did I have that 7 there for? Anyway, you just have to go through all of the factors and find the ones that give you 12 and add up to be 7. And that's like I said, it's still kind of trial and error for that small part, but a very small part of it. After that, it's just methodical. And since you have to know factoring by grouping anyway, then you get to use it here. All right, we're not going to do any of these today because that'll be for Wednesday. So I'll stick around here for a few minutes. If you got any questions, let me know.